Okay, so I kind of wanted to go back and do a few more videos. So this is domain and range. So I'm kind of trying to cover some things that maybe you've forgotten, or maybe some things that maybe you're seeing for the first time if you're in Algebra 2 in 2021 or 2022 or any year beyond that. But if you take a look here, we're talking about domain and range from a graph specifically. So if I'm trying to tell the domain and the range from a graph and whether it's a function or not, I'm going to look at the graph, and I'm specifically going to look at the x values and the y values. So I'll kind of show kind of a projection of this. So we're going to start with this function. So if you take a look at this, what I've got is this nice weird blue shape. And anytime you write domain and range, domain corresponds to the x values of the function, or not function, which you'll see. And then range corresponds to the y values, the range of y values that you get from the inputs. So if I take a look at the inputs here, and I read from left to right, -7 does not have an output for this blue curve. There's no blue curve here. So then I go to -6, and I see no output, so -6 is not in the domain. So the first number that's in the domain, or close to in the domain, is -5. But it's an open circle, which means -5 is close to but not included. So kind of like whenever we were talking about inequalities. And then if you take a look, all the rest of this blue line is solid. So that means there's a point there. So if I plug in -4.5, I get this value, which is -1. So that means that any number between -5, and if you take a look, there's outputs for all these guys, so I'm going to draw this out. -5 all the way to +5, all these values are in the domain except for -5. So the domain would be -5 to +5, and that other 5 is included. Okay, so if you take a look here, I've got these values that are projected onto the x-axis. So you can get those from the graph. And then for the y values, I read from bottom to top. And so I look down here and I take a look, and there's no value for -6. There's none of the graph is down there. -5 isn't in the range, and then -4 isn't, -3 isn't. And the first value I see is -2. And you might be thinking, okay, well, this is open on this side, so maybe it's not open at all. But it's actually an or problem. So if there's a point over here or over here, then it's in the range. So these values, these have outputs, and they're solid. So that is in the range. So I'll use that in green for range. So -2 is included, so there's a point there. So I can start my range at -2. And then it goes all the way to +2. And there's no outputs at 3, 4, or 5, or anywhere else up there. So from -2 to +2, this is what I've got, okay? So -2 to +2 is my range. And so you can kind of see that this projection kind of works pretty well. And then, is this a function? Well, to tell if it's a function, you can do with graphs specifically, not with equations, but with graphs, you can do a vertical line test. So if I draw a vertical line test anywhere on this graph, and I only hit one point of that blue curve, then it is a function for all values of x. So if I take a look here, if I draw a vertical line here and there and here and here, I'm only hitting one point. So all those vertical lines are telling me is whether or not I'm hitting more than one point. So this is a function. So we'll see some that are not functions, but we're going to go ahead and continue. Now, this is a pretty famous function. This is the square function. So if you watched that first video in this unit, goes along with the square function. So if I take a look at this, well, it seems like this line, this arrow is pointing on forever. So if I were to zoom out and look at this graph and keep zooming out, this line would continue on forever. So as far as the domain is considered, if I plug in any value, I'm going to get an output. So these arrows are pointing to -infinity, so the domain is -infinity. And then this right-hand side is pointing to +infinity, right? If I continue to look at this graph and see that it just blows up to infinity, that these x values that I keep plugging in, any positive value is going to get me an output. So all these values are in the domain. Any value I can plug into that function, and I will get a point. Right? 0 is included, -1 is included, -2 is included, and all the way out to negative infinity. So, and then 0, 1 is included, 2 is included, all the way out to positive infinity. So negative infinity to positive infinity is a case for some domain, some functions' domains, or not functions' domains. And then if I take a look at the range, there's no value at -1, -2, or anywhere down here. There's no part of the blue curve here from left to right. But the first part that I see where my function goes through a y value is 0. So if I look here, this output of this function, we have an output for this function at 0. So I'm going to use a closed bracket so it's included, so 0. And then 1's in the domain, any number in between 1, right? All the way out to, and this graph keeps going on forever. So 0 to infinity is my range for this function. And if I take a look here and I do the vertical line test, and remember, it's the vertical line test, only up and down. Left and right has no basis here. It does kind of relate to a function, but it's only for the inverse function that you're looking at. So we'll talk about that hopefully later, but if you take a look here, if I draw these up and down arrows, you will not hit a point more than once as long as they're straight vertical. So this is indeed a function. And then something to talk about is this next graph. And right away, if you're pretty familiar with the vertical line test at this point, you should be able to tell that this is not a function. So if I take a look here and I draw a vertical line in, I will hit more than one point. And so since I hit more than one point, what I'm saying here is that x, this function is, or this relation is saying that x maps to 2 points. And so I can't have an input with 2 outputs. So if this is 1.7, I can't have 1.7 0.5, and I can't have 1.7 3.3. So I can't have 2 x values that match with 2 different y values. So that's what that vertical line test does. It shows us immediately if a function for any 2 points, if I cross through any 2 points, then this relationship, this curve is not a function. So no, it is not a function. But we can still find its domain and range, so we're going to do that. So if I project this onto the x-axis, I'm going to go down from this point. So that is 1 all the way to 5. So if I take a look here, I've got, that's not 1.7, that is 1.7, we're good. So that's 1 to 5, okay? And that's included because these points, even though they're kind of shaped, that's a solid line. So if you think about a flashlight on this object, it would be on this relation. I keep wanting to say function because it's graphed. On this relation, then it would drop the shadow right down on these 2 points. So 1 to 5, and then the range is pretty similar, right? If I take the green values, so from 0 to 4. 0 is there, 1 is there, 2 is there, 3 is there, and 4 is there. So I've got my range is 0 included to 4 included. And that's it. That's all I have to do for that function. So we've got one more, and he's kind of tough, but we will persist. So I've got my domain, my range. And so right here, I've got -4. So I'm going to try and project this onto the x-axis. So -4 is the first value. So there's no value at -5. There's no value at -5 or -6 or any of these lesser values to the left. So the first value I'm going to look at is -4. and then I go to -2. And if you take a look here, there's a break in the graph. There's an open circle here. And so if I take a look here, up here, there's no point. So that is not in the domain. So -2 is not in the domain, and -4 is not in the domain. And then also, over here, I've got another one. So 2 is also not in the domain. And then the last part is if I take a look at this part of this weird line, which is actually a piecewise defined function, this piece of the line continues on forever down this direction. So I could extend that line. I think I might just do that so you can kind of see that this line goes on forever. So it just kind of keeps going in that direction. So what that means is that any x value greater than 2 is included. So let's try and talk about the domain as an interval. So in interval notation, the domain would be from -4, not included, so open parentheses, to -2, union, and remember this is not a coordinate, this is an interval, so I'd go back and look at solving inequalities if this is kind of confusing. So -4 to -2, union, and I'm going to pick it back up at -2 here, all the way to +2. -2 to +2. So what this means is any number between -4 and -2, not including those two numbers, skip -2, and any number between -2 and +2. And then we're going to skip +2. And then if I take a look here, these x values, I keep getting outputs for any x value greater than 2. So 3 has an output, 4 has an output, 5 has an output, 6 has an output, all the way out to infinity, which is what that arrow means, right? It's continuing downhill. So for you guys, it's continuing down this I'm confused. So this direction, I think. Yeah. This direction. Yeah. I was inverted. So, okay. So if I take a look here, the range is going to be quite a bit easier. Since this arrow points all the way down, and I've got outputs to left and right of 1 and 0 and -1 and -2 and -3 and -4, even though it's not outputted over here, I have an output over here. So this y value does hit -4. So if I take a look here, I've got outputs from -infinity all the way up to 1. So I'm going to do that in green actually, so you can kind of see the distinction between the colors. So -infinity, so that is all the way from -infinity to 1. So -infinity comes first, so you read range from bottom to top, so -infinity to 1. And that's it. That's all you have to do for that function. And it is a function, so if you take a look here, if I try and draw in some vertical lines, I'm never going to hit a point on that graph more than once. So function, yes it is. And that is all I wanted to say for this, so I hope that helps.